Welcome. I'm Vick from Portworx,
And my name is Murat Karslioglu. I am the VP of product at Maya Data, storage guy outside and Redis geek inside.
so today we are here to talk about container-attached storage for any workloads. And today we will focus our talk on how it applies to Redis and what are the challenges you will face as you guys are moving Redis-based workloads onto container platforms like Kubernetes, right? So here's the format of it. So before I kind of go into the agenda and the slide deck, just a quick show of hands of how many are using Kubernetes today. Raise your hands. And if you guys are using it in production, can you guys keep your hands up? All right, we got a few of them. And one final question, how many of you are used kubectl this morning or today? All right, we got some real diehard Kubernetes folks. That's great. It's good to have experts in the audience as well as people who are trying to learn about Kubernetes as you guys go on that Kubernetes journey. So what I'll do is kind of introduce the Kubernetes storage for people who are not familiar with the storage primitives in Kubernetes. Then I'll kind of highlight some of the challenges that you may run into and what does the cloud-native storage solutions provide and how do they solve those problems. And then Murat will kind of step into like how are we going to solve those problems and provide benefits to Redis community, and he will expand on those benefits in more details.
And we should really, we will look into why you should care about the storage.
Yep. And then finally, we have a couple demos as well lined up to kind of showcase what that benefit looks like and how you can adopt that with your Redis workloads. So here's a good quote to start with, right? So everybody typically starts and talks about containerizing workloads and moving them to a Kubernetes orchestrator, but nobody tells the storage guy that, hey, this is happening. So data has a certain amount of gravity. So you can't really move your applications inside of Kubernetes from one worker node to another because data, by definition, has some gravity to it. Even a stateless application has some configuration data, some data that is going to persist outside of your container image, right? So how do you deal with those situations? So for those of you who do not know the Kubernetes storage primitives, here's a very quick 10,000-foot level overview of what that looks like. So essentially, when you are deploying Redis in Kubernetes, you have to define a storage class. Storage class basically provisions the underlying storage for you. And then as an application developer of Redis, what you need to focus on is defining a PVC in your Redis deployment spec. And what that essentially does is it carves out a particular size of volume that you need for your workload and attaches it to your Redis container. So that's the relationship between storage class, PVCs and PVs. For Redis specifically, Redis has two types of persistent storage. One is around AOF files, append-only files, and the other one are snapshots. So when you're talking about Redis workloads, you're not only talking about the Redis container, but then you're also talking about persistent data like AOF and snapshot files. So how does Kubernetes improve your storage, right? So Kubernetes K8's project is open source. It's gaining market traction, and it's winning the scheduler container orchestration wars. So I would say Kubernetes has gained a lot of momentum in the last 6 months. It's kind of becoming the de facto container orchestration platform out there. So the primitives offered up by Kubernetes allows you to define storage for your workloads using storage classes. So that actually allows you to provide agility as you are bringing workloads onto Kubernetes. And one thing that Kubernetes is doing is it's making all the infrastructure agnostic to the underlying cloud providers, right? So in the keynote, you saw AKS, GKE, all the different hosted managed versions of Kubernetes mentioned. But as a developer, as a Redis developer or as a Redis architect, only thing you need to focus on is can I use those API calls across clouds or across different cloud providers, right? So Kubernetes is giving you that level of abstraction. So one quick way to look at it is Linux kernel. I'm using some parallels here. Linux actually allowed for the computing to be adopted very well in the cloud because it was open source and it provided that same level of kernel guarantees. So that allowed for other innovation to happen on top of the Linux kernel. So Kubernetes is doing something similar for the container orchestrated workloads. Now let me talk about some of the challenges that you may see with Kubernetes. And the first one that may come to mind is Google Cloud has persistent disks. Azure has managed disks. AWS has EBS, right? They all have different API calls to instantiate themselves. So how do you make sure that when you're developing your application that you abstract away those deltas and use a consistent API call in your application so that you can quickly move it from one cloud to the other? So that's one challenge you need to be aware of. Another challenge is, a lot of the traditional storage providers like SAN arrays or, hardware vendors that only work on your on-prem data center, how do you take that set of assets and move it to the cloud? If you have your own data center, it's very hard to do. So what those vendors are trying to do is they're sort of focusing on providing some sort of plug-in architecture, right? But it is a challenge because each of those implementations are going to be slightly different. And as a Redis developer, you want to focus on developing your application, not worrying about the infrastructure deltas that may exist, right? And another one that's worth highlighting is around data portability, right? I think based on the quote that I showed you earlier, it's the same concept. Is Kubernetes? It's very ephemeral, dynamic. Pods will get rescheduled on different worker nodes. So how do you make sure that when your Redis pod gets rescheduled, how do you make sure that the data that you need exists on that other worker node, right? Because Redis is extremely fast. It can do fast data ingest. When you bring it up in some other worker node, you want to make sure that the data is there locally so that Redis can quickly rehydrate the data and bring up the application in a lot more efficient manner. And one of the other big challenges around container storage is around how do you scale and how do you provision storage for your containerized applications, right? If you have your own data center, how do you scale to a different data center? How do you move data across different data centers? How do you add capacity when your awesome Redis app is hitting hundreds of thousands or millions of requests per second? How do you scale efficiently with persistent storage? So these are some of the challenges that you will see when you are trying to take your Redis applications to a container orchestration platform like Kubernetes. So there are quite a few challenges. So what is the solution? So in our opinion, we think the solution is around cloud-native storage. And let me explain why cloud-native storage is a good fit for Kubernetes and microservices applications running on Kubernetes. So what cloud native storage does is essentially abstracts away these deltas that you may have around SSDs or hard drives or SAN arrays that you may have in your data centers, or differences between the cloud providers' storage systems. So if you use a cloud native storage, those deltas will disappear and you will be left with one API call that you can make across different clouds. So then you're able to do multi-cloud, hybrid cloud stories a lot more efficiently than you would if you were using an on-prem solution only, right? Another aspect of cloud native storage is the cloud storage interface initiative that has been going on alongside of Kubernetes. So what's cloud storage interface does, it abstracts away implementation details about the storage provider, right? So we have a couple of us on stage here today, Portworx and MayaData. We have slightly different implementation approaches to the problem, but both of us are going to be using CSIs, right? So again, by using CSIs, it's giving you additional capability. It's giving you standardization around role-based access controls, authorization and authentication. Snapshots, and if there's a whole list of 6 or 8 features that CSI provides. So when you're evaluating a storage provider, you should consider a storage provider that has CSI implementation in their solution. So that will make sure that you're not getting a vendor lock-in solution. It's vendor neutral. Another one is around data portability, right? So whatever solution you pick, the cloud native solution, it should provide you with these basic constructs of data replication, right? So it should support data replication, either replication level 2, replication level 3, so that you can address your use cases, high availability, constraints or requirements. Another one is around encryption. Your storage system should support encryption at a container level so that when you have different Redis use cases like Redis search or Redis graph, you are able to encrypt those data sets with different encryption keys and other things, right? So again, you want to focus on getting vendor neutral solutions and make sure they have integrations in place with key vault services like Vault Server from Hashi or other. Scalability is around cloud native storage solutions. They provide scalability by default because their form factor is meant for container systems, right? So their control plane as well as their data plane is being managed in a cloud native, container first way so that it can grow as your Kubernetes cluster grows without a lot of intervention required from your side. And then obviously, one of the key things that helps the cloud native storage and Kubernetes to work together is around thin provisioning. Thin provisioning, for those who are not quite storage buffs, is when you provision an EBS, right, and if you say 10 terabytes, it automatically has to provision 10 terabytes and it will start charging you 10 terabytes. By thin provisioning, what we mean is if your application is only using 4 terabytes right now, it will only provision what you need with a little bit of headroom. So it will help you along with cost management issues if you have concerns around those dimensions. So I've been talking about cloud native storage solutions for stateful applications. So what does cloud native storage mean, right? So here's my quick sort of interpretation of what it means. First of all, just like Redis, it should provide you with an API which you can call to provision your storage. So it should be very declarative, right? So you should be able to specify in your Redis application's deployment spec or an application YAML what kind of storage class you should be provisioning, what kind of I/O are you looking for, what kind of replication strategy you want. so that you can audit that and do a GitOps kind of operations and check that in, and then have that go through into your production environment. Another one to focus on is around security. So security, if you use CSI-based implementations, you're going to get that by default and a few other features, but role-based access control, right? Kubernetes has role-based access control for the Kubernetes clusters. So how can we make sure that your Redis application is not accessible by, let's say, a SQL owner, application owner, right? So you want to make sure that it has that segregation built in, and then you're able to encrypt the data according to your needs, right? So those are some of the key tenets of a cloud-native storage system. Another sort of aspect, and I think Redis Labs did a operator-based approach for their Redis Enterprise, and that's a key when you're talking about cloud-native storage. You want to have integration points. You want to make your system be observable, right? So that means you want to integrate with Prometheus. You want to come up with some nice dashboards like Grafana dashboards at a bare minimum so that you are able to monitor your critical storage needs and make sure you are taking proactive steps and not reactive steps, right? So, and obviously, if you're doing cloud-native storage, and Rob touched on operators, both of our solutions are using Kubernetes operators. Now, Kubernetes operators, in one sentence, is around extending the Kubernetes APIs with custom resource definitions so that you can do a few more additional operations that currently don't exist in a Kubernetes API. So both of our solutions allow you to do that, allow you to introduce custom controllers and custom Kubernetes objects so that you don't have to worry about the storage lifecycle, right? That is being offloaded to folks like us so that you can focus on your Redis development. So that's a very quick introduction and overview, and I think I'll hand it over to Murat to...
Yeah. Thank you, Vick. Yeah, it's been really helpful. So, like Vick said, application has changed and someone forgot to tell storage. And when you look into running from the developer perspective, running database and how they are trying to achieve agility. So if you want to get to the level of service cloud providers are providing, the bar is really high because what is happening is why developers or we prefer to use cloud or services from cloud is because they are single click away. And now we have operators, Redis operator, and also some open source operators for all type of databases. But there is this also a never-ending debate around who should be taking care of replication, or I'm running my database, why, and then my application is taking care of the replications, why would I need a storage? So yes and no. Why would you need storage? Because storage is not just about the replication. You can choose not to have a replica with your storage classes that I will take a look into shortly. But storage, especially cloud-native storage, is just not about providing the storage like in a legacy storage way. So it is more like changing how your application works and giving you agility. In many cases, in a production environment, what we see, developer wants to deploy a Redis on a VMware environment on top of Kubernetes, but they need to go and ask for a storage from a storage admin. So that may take maybe best case hours or may take days. So this kind of agility is available or provided by cloud native storage. So I also I used to call this approach in the beginning application defined storage. It is in a way really magical that finally applications can decide what they want without the middleman in between. So like I said, the bar is really high because when you try to manage your own database as a service, expectation should be a click away, really simple to use. And it should just provide you the database. And why would you, again, run your own environment or run your own database as a service if you can get a similar service from cloud? I'm not counting the cost part because if you look at the CIS perspective, if you look at the cost, the biggest cloud cost is usually the storage because developers tend to over-provision storage in the beginning because they don't want to run into that issue later that they cannot change the storage size, but you end up paying or overpaying for the storage. And other part is the lock-in. So once you use one vendor API, you are pretty much locked into that environment, and this is a tough decision. So with a cloud-native approach, you get that freedom. You can run anywhere you want. Developers will not even notice the difference because they are calling the same storage classes, and your cloud-native storage decides how to place the data there. And then a little bit of comparison, what you expect from database versus storage. Yes, databases provide application-friendly semantics. Different flavors of database are optimized for different requirements. And heavily depend on storage layer, whether consuming raw disk or using file system on virtual disks. So idea is today, when you create database on top of your file system, you introduce another layer that might be, so in that Redis case, Redis is in memory, but in other database cases, you use some type of disk in some form. So we can also, with cloud native approach, based on the environment, we can also eliminate that file system overhead. What is expected from storage? Read, writes data to underlying disks. So you may have a different layer or different tiers of storage, automation of that tiers. And one thing that we realized building storage solution on top of Kubernetes itself is, in the beginnings, Kubernetes did not care about storage at all because it was designed for stateless application. Now we have stateful application. We need to think about what is in the background or what is my storage layer. So what I'm trying to say by that is if you are running on-prem, let's say you have a disk failure. Good luck with finding which disk failed, because if you don't have a RAID array and you are using a bunch of disks, then it is not going to magically start blinking because the disk failed. That kind of feature you would expect from legacy storage appliance. So to be able to do that, you need to build some logic, and you need to build Kubernetes CRDs, custom resources, and then be able to natively query all the disk resources and get disk health and everything from the Kubernetes APIs or Kubernetes way of managing your clusters that I will show in the demo shortly. And let's look into advantages that we think would be helpful for Redis. So you don't need to manage local disk. If you are running Redis on-prem, container-attached storage takes care of it. So you just call the storage class, and then wherever that environment is, storage magically carved from the backend. Can be anything, can be legacy storage backend, Ceph, EBS, or NVMe's, local disk, spinning disk. So you can, this is a big advantage really, start with small storage and grow as needed on the fly. So again, like I said, if you are running on cloud and getting an EBS volume, you will most likely ending up over provisioning and paying for the storage that you will never use. In CAS approach, you can actually get exact storage capacity that you need, and maybe even thinly provision, claim that you have that capacity, and grow it and actually add the physical storage when you need it. This, in some research, I think there was a percentage, from the beginning, you will end up with at least 30–50% of saving. Nodes are underutilized. Yes, yeah, one benefit of Redis, so which I like, and we do the same approach in our storage, single core approach. So because of the context switching and type of latency and IOPS that you require these days, CPU becomes our bottleneck. But with Redis, because it is a single threaded, you can actually utilize CPU much better if other resources allows you to do. So what I mean by that, in most environments we see, okay, you get to some utilization, but other resources are blocking you. This might be storage or memory. So by abstracting storage or not being locked to one place, you can actually migrate workloads live and then move into maybe another host that has more CPU, memory, or storage. We unlock that availability feature as well. So yeah, don't judge your developer. They have their own way of deploying Redis. This might be preferably operator, but yeah, I used to use deployment or stateful set, and I have a demo. I think I will deploy stateful set again here. But whichever you prefer, there is an option for storage. So what I mean by that again, we see in production some users, I would say probably 30–40% of what we see in production Redis on Kubernetes, developers or I should say storage admins or storage architects still prefer to replicate Cassandra with storage as well. That again, you can choose not to have a storage replica and then let your application take care of it. But you can, as a backup, you can also have multiple replicas of your storage, just let's say to protect your snapshots if you are not backing up to S3. Again, you can also use storage snapshots to do the same and back up to S3. So that way, wherever you go, or if you lose your node, or if you lose one site completely, you can still recover data. Database consistent snapshots can be cloned and mounted in a CI/CD pipeline. We see that again a lot in, I would say, production. So yeah, you run into an issue, you take a snapshot of your complete application, not just the storage. I mean, yes, Redis has a capability, you can take a Redis snapshot, but if you are in this mode, troubleshooting, you want to give the exact environment to your developer, you can take a complete snapshot of including the application path, containers, and the storage, and just in 10 seconds bring it up somewhere else. So you can look into the same data. And again, last point, cloud native storage can mount backups in available environments to avoid backup it on production environments. So some of them, this last slide, benefits to tuned CAS applies to Redis and overall other applications, other databases more probably. You can define tiers and you can automatically create those tier of storage to place your data onto different grade of storage, NVMe, SSDs, spinning disks. And we both, Mayadata, OpenEBS, and Portworx have solutions to allow transparent data movement online to better tier or across clouds as well. So you can move your workload across cloud, or you can move your workload across different tiers. And so, of course, this comes with cost saving. Developers probably don't care, but CIOs do. Developers care wherever they run it as easy as possible. So you get, thanks to team provisioning and resizable storage backend or other benefits, you get 40–50% saving. So I'll get into demo very quickly and how to build your database as a service again. Some considerations here. It needs to be, it should not require any ops, it should just works, and it should scale. And plus, it would be great if it costs less and more flexible without any vendor lock-in. So we have open source, OpenEBS is an open source project. You can find the repository, and we have the same demos that I'm gonna show there in the repository. Also Katakota training if you wanna, if you don't have an environment and still want to play with OpenEBS. So I'll jump into my environment here. Let's see if you can see the screen. Oh, okay. 190. So I just SSH into my setup on, I think, AWS. Yes, looks like AWS. It's a clean setup just to show you that. Get nodes, one master, 3 worker node, and I don't have anything deployed here. Let's check also namespace OpenEBS, nothing here. So how do I get started? From the repository link, I'm gonna apply one YAML file, which is the operator for OpenEBS. So you can see kubectl apply -f file, OpenEBS operator, and just watch kubectl get pods -n OpenEBS. So what is happening on the background? Like I said, there's a node disk manager that takes care of the disk and watches getting deployed. Might be a problem with one of the nodes, but that's fine. So and then API server and some other operators getting deployed. So this takes less than 34 seconds. So I have my storage solution deployed. I will just quit. Okay, and then now more files are getting created. So in 30 seconds, I got the OpenEBS deployed, and I have, like I said, some demo files. I will clone my repository to see the demo files. Let's say git clone, paste, and got the clone of the repository, OpenEBS, Kubernetes, demo, I think Redis, yes. So I have a standalone or stateful YAML file. This might be old, but let's take a look. Redis, what's in the stateful? So this is a basic stateful set. It deploys Redis with 3 replicas as a stateful set. The only thing I need to set here is storage class. So I want my Redis stateful set to use this OpenEBS Jiva default. We have some default storage classes created for simplicity. Use this and use 1 gig and also create the service. So let's very quickly kubectl get storage classes. I have this OpenEBS Jiva default. If you look into what's in that storage class, OpenEBS Jiva default. So what it says, you can change this, but just to explain the demo. So storage class says create 3 replicas. Okay, the only thing I need to do now, just apply this Redis stateful set YAML and watch. Kubectl get pods. Let me resize my screen. So what is happening here again? So Redis stateful set is getting deployed. It's pulling the container, but before it started that, like I said, application defined storage. Application asked Kubernetes APIs to give storage persistent volume with 3 replicas. So you can see one, it calls itself a controller, and then 3 replicas of that storage created on separate nodes, because I had 3 worker nodes, so it automatically distributed that storage to 3 nodes. I got my PV created. Now it is pulling probably containers from Docker Hub, creating the Redis, and it will be up in probably seconds. But in the meantime, just to prove that get PV, so you can see my persistent volume is created, and the status shows as bound. So storage is there, and we are expecting now Redis stateful set to get up. So after this, so I am done. I have replicas created. I got my storage mounted to Redis, and I will just last part. I will show how it looks from the storage perspective as soon as it gets created. Okay, so Redis, if you remember that stateful set required 3 replicas. So first one is done, and you can see 3 more replicas for the second pod is getting created. So and after the third one, it will be complete. So so I can switch. So this is gonna be quick. So this is the visibility part. I am looking at my, and this is a SaaS solution dashboard from Maya Data again. Gives you a simple visibility toy. It's also free. So you connect your cluster, gives you capacity, volumes, how they are distributed, how his storage is doing. And my application, right now I have 1 Redis stateful set deployed. And if you are curious, really, you can dive into storage. And then from this view, you can take your snapshots and clones as well. So this is showing that storage is using, I think it's not visible, but yes. It is showing storage class. This Jiva default is used by Redis stateful set that has persistent volume claims under, and if I click on this, you can see it shows the persistent volume. And then from this view, you can take a snapshot. Let's do that. Yep, I got a snapshot. It has now a snapshot. If my other coworker developer needs that copy of that snapshot, I just clone it and give him the PV. He can connect and access to the same data. So this is pretty much it, and I will give microphone back to Vick for.
All right, so I will do a similar demo, and what I'm going to do is have it be a tutorial available to you guys after RedisConf. But for today, please follow the bottom link, and you're welcome to do the demo with me as I walk you through the steps for doing Redis in Kubernetes with cloud-native storage. So I'll give you guys another 10 seconds to kind of write down the bottom URL if you guys want to follow along. But let me quickly, oops, there we go.
Oh, yeah.
So what I'm going to walk you guys through, and you're welcome to follow along for this session or later on today, is I'm going to show you how to do HA Redis using a cloud-native storage solution. So one of the first things we're going to do is kind of, okay.
I can sign up with mine very quickly, or should we? Hopefully. Yeah. Let's see.
But the idea behind this demo is essentially what Murat showed you earlier in his demo, right? So is how can I do high availability?
Yes.
And then essentially we're going to just walk you guys through the demo itself. So the first thing you do is essentially initialize your Kubernetes environment. So all these commands are pretty much ready for you to do. So you can click along, and now you can see on stage that, hey, we have a Kubernetes cluster with 4 nodes. Then the next step we do around it is we want to look at, hey, what kind of systems are running on the Kubernetes clusters. From a Portworx perspective, it gets deployed on a Kubernetes cluster as a daemon set. So every worker node of Kubernetes will have a Portworx pod running on it, right? So it's dynamically scalable. As soon as you scale up your worker nodes, the number of instances will also scale with it. And then as you follow along, what you want to do next as a developer is kind of look at how you want to initialize your storage class, right? So one of the things you want to do here is take a look at the deployment set. Oops, did I miss a step?
Command line got, I think, stuck here.
Yeah. So I think you guys all logged in at the same time. Let's see here.
Yeah, that VM got stuck.
Uh-oh. So thanks for participating on a live demo and trying to follow along. But let me go back to the slides here. We have 5 minutes anyway. You're welcome to try this scenario after the session as well. Please follow the top link and learn about how to deploy a storage class, learn about how to connect your PVCs to PVs. And I do want to open it up to questions. We have about 5 minutes left. So I think we can both answer any questions you guys may have at this point.
A question there?
Mike is coming around, so please wait for the mic to ask your question. Go for it.
You have a slide, so like 2 ways to deploy. One is deployment, one is daemon set. Can you elaborate more the pros and cons, when to use what?
Yeah, was it from my slide?
So are you talking about Redis itself or the storage?
One is daemon set, one is deployment, right? That's a slide say you can use either. Can you tell us more pros and cons, like when to use daemon set, when to use deployment?
You want to use daemon sets if you want to deploy your container on every single worker node of Kubernetes. So traditionally speaking, you want to use a daemon set for that scenario. Deployments are typically used by applications like Redis. In Redis case, you will most likely use a stateful set, which is a certain type of a deployment. Does that answer your question? Yeah. All right. Any other questions? And all these solutions work on, PKS, GKE. So any of the cloud providers, managed hosted Kubernetes, or you can do it on-prem as well. So thanks for attending, and thanks for participating in my scientific poll from the start.
Thank you. Yeah.
Thanks, guys.